Hi everyone, nice to see you all today. Today we're going to go over some problems related to acids and bases in chemistry. I'm going to teach you how to calculate pH and pOH, which is a very fundamental concept needed to know when you're dealing with acids and bases in chemistry. In subsequent lessons, I'll build up upon that, but first let's cover our basics. So I'm going to start off with this problem in which it reads, a solution of HCl has a proton concentration of 2 times 10 to the negative 2 moles. What is the pH and pOH of the solution? Okay, let me write this down real quick. Our solution concentration is going to be 2 times 10 to the negative 2 moles of H+. After this, I'm going to move it to the next page. Yep, just like that. Alright, sweet. So typically when we have concentration, we notate the concentration with brackets. That's what it always means. So our formula for pH is going to be negative log of the concentration of protons. Yeah, so negative log H+. Negative, right there. And what I want to impress upon you with is that the P in front of pH always means negative log. So for example, when I write down the formula for pOH, pOH is going to also equal negative log. But instead of H+, this time it's going to be O minus. Negative log of OH minus. Sorry, OH minus, not O minus, which is hydroxide. And the same notation applies. Now, when we talk about pKa, which I'll cover in the subsequent video, pKa also has the same logic applying, in that the P in front of the Ka is equal to negative log of Ka, which is the acid dissociation constant. So that's how it ends up working right there. Yep, P is equal to negative log. I think you start seeing the pattern. So in order to calculate this, what we're going to do is simply take the negative log of 2 times 10 to the negative 2. Now, we could do this with the calculator. However, I will show you a method in which you could solve this and get a close approximation without a calculator. So I'm going to color code different parts of this number. I'm going to color code the 2, which is called the antithesis. It's the thing that comes before the exponent. So 2 times, and I'm going to put the 10 in orange. That's just the power to which it's being the base of the exponent, actually. And then the negative 2 is the power to which the exponent is being raised to. So in order to get our final answer, actually, let me erase. I'm going to erase this negative because the negative won't be needed, as you'll start to see. I'm going to put the negative in black, and then I'm going to put the 2 in pink, just like that. So what we're going to do is we're going to take the exponent, just the 2, ignore the negative. We're just going to take the magnitude of the exponent and subtract it by 1. So 2 minus 1. 2 minus 1 makes 1. Now, once we get that number, we're going to put a decimal behind those 2. So a decimal goes right after the 1. Now, what we do after that is we take the 10 and subtract it by 2. So when we take 10 minus 2, we get 8. So our pH should roughly equal 1.8. And to check this for sure, I'm going to show you the same exact calculation but with the calculator. And it will be very close to what we got. Negative log 2 times 10 to the negative 2 power. And voila, we end up getting about 1.7 right there. Very close. So that is our answer. I'm going to write as our final answer as being 1.7 in case those of you are in classes that require calculators. However, if you're doing this for the MCAT exam, this trick right here is something that you need to know because you will not get a calculator on that exam. And it's something that I personally like to call the ninja trick. Very good trick for you to know in case you don't have access to a calculator. And even if you forget your calculator on your exam day for chem, you'll still have this trick as a backup when trying to figure out negative logs. However, for the answer, I'm just going to put pH is equal to 1.7. Now, we're not entirely done yet because we need to figure out the pOH. Luckily, the formula for that is very easy because pH plus pOH equals 14. So what we need to do to get the pOH is subtract the pH from both sides, like so. I'm going to put minus 1.7 because that's what the pH is equal to. So if we take 14 minus 1.7, we end up getting a pOH of 12.3. So that will be the pH and the pOH of our HCl solution. And HCl is a very strong acid, so this makes a lot of sense that the pH would be low and vice versa. The pOH would be very high. It's a very good first problem right there. Now let's repeat this, but this time with a base. I'm going to clear this up and let's move to our next problem. Now here we have a solution of NaOH has an H plus concentration. Let me write that down real quick. It has an H plus concentration of 8 times 10 to the negative 12th moles. What is the pH and the pOH of the solution? So let's go down to our scratch sheet of paper here. First off, we can figure out the pH one more time by doing negative log of 8 times 10 to the negative 12th moles. That's going to be our pH, like that. And let's go ahead and repeat the ninja trick, but this time let's do it a bit more quickly with math. So here we have 12 minus 1. That's going to end up making 11. And then 10 minus 8 is going to be 2. So we have a pH of roughly, 10 minus 8. Let me rewrite that real quick. 10 minus 8 is going to equal 2. So we have a pH that's going to equal 11.2, roughly, if we were to estimate it. However, I'll pull out my calculator for those of you who want more of an exact answer. So I'll write the final answer expressed, what I got in my calculator. So here, we're going to get negative log of 8 times 10 to the negative 12th. And I end up getting a pH of about 11.1, as you can see right there. 11.1. That's what it will roughly be. So again, using the same rule, pH plus pOH is equal to 14. What we're going to do to figure out the pOH is subtract 14 minus 11.1. And as a result, we're going to end up getting a pOH that is equal to 14 minus 11.1. That's going to be equal to 2.9. That's going to be our pOH. Let me box in my two answers right here. And it makes a lot of sense given that NaOH is a very strong base. So it would have a very high pH, meaning that it has a very low proton concentration. And likewise, it's going to have a very low pOH. Okay, this is pretty straightforward so far with pH and pOH. Just note that it's a negative log notation, and you can use the pH plus pOH is equal to 14 to figure out the other variable you need once you have the first one solved. Now, I'm going to put the third one out here as a tougher one, which is going to relate more to finding moles. Now, let's see what our given information is. So here we have 250 milliliters of a solution of HCl. Has a pH of 3. So our pH is going to equal 3 right here. Now we have two questions. What is the concentration of protons and how many moles of protons are present? So Now they're asking us for the number of moles, which could potentially be used for stoichiometry and potentially for things like titrations and stuff like that, which I'll go into more detail in subsequent videos. Right now we're just covering the basics of acids and bases, covering pH and pOH. So this is our tricky question that we have right here, because now we have to work backwards. Our pH is equal to 3. Well, pH is going to equal negative log of the H plus concentration. So we're already very close to solving our first part of the answer. However, now we have to know how to manipulate logs. So this question is really more of an algebraic question rather than a chem question. What we're going to do is negate the log, so times it by -1 on both sides to get -3. And because this log is implied as log base 10, in order to get rid of the log, we actually have to raise it to the 10th power, like so. And we raise the other side to the 10th power. Hence, we're going to get our proton concentration. Our proton concentration is going to equal 1 times 10 to the -3 moles. Always put moles. Be careful, because I know some professors and teachers like to dock you if you don't put your units right. And it's always just good habit anyway to put your units. So that's the first part of the question. We solve for the proton concentration. However, the next part is asking for the number of moles present. Well, molarity, big M, is equal to moles over liters. And here we have a concentration of 250 milliliters. So what we need to do is convert milliliters to liters. And as a conversion factor, there are 1,000, which is the same thing as 10 to the 3. 1,000 milliliters make up 1 liter. So what I'm going to do to change 250 to milliliters to liters is that I'm going to move the decimal place 3 places to the left. Because think of it this way. You need 1,000 tiny, tiny, tiny little milliliters in order to make up 1 big, giant liter. So what that says is that it's going to take way less big liters to make up 1 teeny tiny liter. Hence why I'm going to move it to the left. Because now liters is going to be expressed as a smaller number due to the fact that the unit is way bigger. So I'm going to do that, and subsequently this is now going to turn, 250 milliliters is now going to turn into 0.25 liters. That's my work behind that. I'm going to erase this back just to show you that it's the same exact thing. Let me write the 250 one more time. 250 milliliters is going to equal to 0.25 liters. And the reason why we have to convert that is because the units of moles uses liters. Okay. And so here's what I'm going to do. We already established the proton concentration is 1 times 10 to the -3 moles. I'm going to choose to rewrite it as moles over liters, using what I like to call the railroad track method in order to cancel out the liters in order to get our desired moles, which is a good thing to use when doing dimensional analysis problems like this. So here we have moles over liters, and I'm going to multiply it by 0.25 liters. These units are going to cancel out. The liters are gone. Now we're left with moles as our desired unit. And subsequently, I'm going to rewrite this in a much nicer form, because in chemistry a huge thing is that you need to get good at scientific notation. So instead of 0.25, I'm going to write it as 2.5 times 10 to the -1. And afterwards, our answer is going to end up equaling to 2.5 times 10 to the -4 moles of protons, H plus. And that is our final answer right there for chemistry. So you see how pH can be used to calculate not only hydrogen ion concentrations, but if you have a given volume, it could be used to calculate number of moles present. And this can be extremely useful for science experiments such as titrations, which I should definitely go over it in a different video. But for now, we're starting off with the basics of pH and pOH. In the meantime, I hope that this has helped you and helped you gain a further understanding of acids and bases, at least the very beginning part of it. Thank you so much, and I look forward to seeing you in the next one. Be sure to like and subscribe this video so I can keep producing content like this even further. Take care.